All right, hey Honors Chemistry. I wanted to provide another video to make sure that we understand how to sift out important information to write a balanced chemical equation and then calculate a percent yield or know how I have a percent yield question. So let's look at this first question. And this is from worksheet number 2. It says determine the mass of carbon dioxide. So this is something that I have to find that should be produced in the reaction between 3.74 grams of carbon and excess O2. And then it says, what is the percent yield if 11.34 grams of CO2 is recovered? Hold on, I have to get my calculator. But think about this for a moment. Which of these is my theoretical yield or going to help me get my theoretical yield? Which of those are my actual yield? And so, if I'm looking at this question, it says determine the mass of carbon dioxide. So this is going to be that should be produced. This is theoretical. And I can get the theoretical from the BCA table or direct mole ratios. In the reaction between 3.74 grams of carbon, this is given, and that's my reactant, and excess O2, what is the percent yield if 11.34 grams of CO2 is recovered? So how do I write this chemical reaction? It says determine the mass of carbon dioxide that should be produced. So if it's produced, carbon dioxide, which is CO2, is a product. And then things that are reacting are carbon and oxygen. So here's my balanced chemical equation. C plus O2 yields CO2. And that's a nice simple balanced chemical reaction, 1 to 1 to 1 to 1. And I'll begin to construct my BCA table. All right, and it says should be in the reaction of 3.74 grams of carbon. So initially I have 3.74 grams of carbon. When in doubt, always convert to moles. I need moles. Well, the molar mass of carbon is about 12. So 3.74 grams of carbon over 12. I'm just going to do 12 grams per mole because grams divided by molar mass is moles. So 3.74 divided by 12, I get 0.3, I'm going to say 312 moles of carbon. Now, that's what I have before. It starts with 3.74 grams, and those 3.74 grams are 0.312 moles. So I'm going to put that here. And it didn't give me a number for oxygen. It just said it was an excess. So excess. And we don't have any CO2 to begin with. Now on my change in my C, I'm subtracting from my reactants. I'm going to subtract something here, and I'm going to add to my products. Now this is a 1 to 1 to 1 mole ratio. So if I'm using 0.312 moles of carbon, the amount of oxygen I should use in a 1 to 1 ratio is the same amount, 0.312 moles. Even though there's excess, I'm using a little bit of that excess, and I'll get excess later. And then since it's a 1 to 1 mole ratio, and if anybody needs help showing this work, I'll have 0.312 moles of carbon times 1 mole of CO2 over 1 mole of C, and I get 0.312 moles of CO2. This is dimensional analysis, what I want, which is the amount of CO2 over what I have, which is carbon, and this 1 to 1 comes from the balanced chemical equation. So I should get 0.312 moles of carbon dioxide forming moles of CO2. This that I get in the BCA table only using the amount of reactant, this is my theoretical. And then it wants it in grams, right? So it says what grams should form. Well, the molar mass of carbon dioxide is 44 grams per mole. If you forgot how to do that, 2 oxygens, 16 and 16 is 32 plus 12 carbon, 44. So I'm going to multiply 0.312 moles times 44 grams per moles. Because if I want grams, I take my moles and multiply it by my molar mass. So 0.312 times 44, I get 13.73 grams. That's my theoretical. Right? So how much am I supposed to get? I should get 13.73 grams. What is the percent yield if 11.34 is recovered? When it's saying it's recovered, it's the amount that you actually got. So if I have theoretical and actual, percent yield is actual over theoretical times 100. So I'm going to do that math over here on the side. Actual is 11.34 over theoretical, 13.73, times 100. And if I do this math correctly, 11.34 divided by 13.73 times 100, I get about 83% yield. So that is a quick walkthrough of a question. I'm probably going to post other videos and other questions if you just want to watch one or watch more. So stay tuned if you need more examples. I'll probably do the other examples on this sheet.